Hello everyone, welcome to Pratibha Tech. In this video, we will solve the problem of the day question on Geeks for Geeks for 9th April 2023. The problem statement for today is special digits. This problem is based on combinatorial and mathematical operations. Let's now open this problem to solve it. Let's go through and understand the given problem statement. Here it is said, you are given 5 integers n, a, b, c, d. Let us say all the integers of length n having only a or b in their decimal representation are good numbers or good integers. Also, among all the good integers, all those integers whose sum of digits contain either c or d or both are the best integers. So here what we have to do, we have to find the number of best integers of length n. Since the number of best integers can be huge, print it 10 to the power 9 plus 7. That means that those number has to be modulo with 10 to the power 9 plus 7. Okay, so here it is said that we will be given with 5 integers and we have to formulate some good numbers that is consisting of only a and b of length n. And among those good numbers, if we add the sum of those good numbers, then if those summed up numbers contain c or d, then those numbers can be considered as the best numbers. So out of those good numbers, we have to find how many best numbers are there. Okay, so let's go through and understand the given problem statement here in the given examples here. Here it is said n is equal to 2. That means the length of each integer should be 2. A is 1, B is 2, C is 3, D is 4. So here the output is 2. Here the following are the good numbers, that is 1 1 2 2 2 1 1 and 2 1. So here we can see that it is given that length should be 2 and all the integers should be formed using A and B only, so that can become a part of good numbers. So when we try to formulate all the possible numbers using 1 and 2 with maximum length of 2, so here we can see we get these 4 numbers. Out of these 4 numbers, when we try summing up all the digits of these 4 numbers, then we have to find which all numbers is giving 3 or 5 or both. So we can see 1 2 and 2 1. When we add them, then they will give 3. 1 plus 2 is equal to 3 and 2 plus 1 is equal to 3. So that's why these two are the best integers, because the sum of digits of 1 and 2 2 are 2 and 4. And they are not equal to C and D. C is 3 and D is equal to 5. And 2 and 4, when we add 1 1, that will give 2. And when we add 2 2, that will give 4. So this will not fulfill that criteria. So 12 and 21, these two are the good numbers which are also the best numbers. Okay. When we go to the second example, here it is said that length is 1, A and B value is 1, but C and D value is 2 and 3. And here we can see that since length is 1, and the combination of the possible numbers can be formed using A and B, that is also 1. So we have the good numbers as 1 only. So the sum of digit 1 which cannot be equal to C or D. That's why the answer is 0. Okay. I hope so the problem statement and this example is clear to you. Okay, so this problem can be solved using mathematical concept of combinations. For a given value of n, we need to first find the different good numbers possible. Then the number of best numbers that can be found by taking the sum of the digits in the form of ai plus b into n of I, which ranges from 0 to n. A number is considered to be best if it contains at least one digit that is equal to either C or D. Okay. To solve this problem, we iterate through all the possible values of I and calculate the good number and the corresponding sum. For each sum, we check whether it is the best number or not. This and how we do it? This we do by checking whether this contains either C or D as a digit. If it is the best number, then we add the corresponding NCR value. That is that mathematical formula that whatever we do in permutation combination, NCR, that means the number of ways in which we can select R from N. So that formula. So we add the corresponding NCR value to the answer, where NCR is the binomial coefficient that represents the number of ways of choosing I from a set of elements n. Okay. So let's understand this approach in a better way with this example. So when we take the example here, let's take the given example here, the whatever we have seen in the first example here, whatever it is given, that we are taking that example here only. So what we are doing in the first step, we have to find the total number of good integers of length 2 that can be found by the number of ways in which we can select the position of a and b. Okay, so for example, when I is equal to 0, okay, when I is equal to 0, what does this mean? That I is equal to 0, I is equal to 0 means we are selecting 0 places for A and remaining 2 places for B. That means here, what is A is 1 and B is 2. So we are not selecting, so when I is equal to 0, then that time we are not selecting any one, we are selecting both 2. So the number will be 22. So we have only one good integer, which is 22. Okay, when we have I is equal to 1, okay, when we have I is equal to 1, so in this time what do we say? We are saying that we will be selecting one position for A and one position for B. So here we get two good integers. Those will be 12 and 21. Okay, so how we get 12? We have given first slot for A, second slot for B. The different combination, first slot for B and second slot for A. Okay, that means we are selecting one A and one B, and these are the two different combinations. Actually in the answer we need to find this combination only. That means if you are giving some slot for I and some slot for n minus I, so for A and B, so how many such combinations will be present? So we have to find that only using NCR. Okay, so this was the one scenario. Now if we go to I is equal to 2, so here what do we say? Here it means we are selecting both combination of one only. That means we are giving both slot for A only. We are not selecting any B here. When I is equal to 0, then we selected both combination of B. Here we are selecting both position of A only. So both position of A only, that means 1 and 1. So this is the one of the good number. So here we can see the total length of the total number of good integers of length 2 is 4. 1, 2, 3, 4. Okay, so now counting the number of the best integers among the good integers, now we have to find that one. We need to check if the sum of the digits of each good integer obtained in this step is containing only 3 and 5. So when we do summation of all these, okay, when we do summation of all this, then it will become sum of 2 plus 2, that means 2 plus 2, it will become 4. When we do summation of this one, it will become 1 plus 1 or 2 plus 1. So here the sum will become 1 plus 2 or 2 plus 1. So here the sum will become 3, and here the sum will become 1 plus 1 is equal to 2. Okay, so yeah, so this is the same thing. That means when I is equal to 0, we have only one good integer. So when we add, the sum is equal to 4. When I is equal to 1, we have two good integers, so which are 12 and 21. The sum of the digits is 3. Okay, and when and the same happens for 21 as well. Even the sum of those two digits is also giving 3. And for I is equal to 2, we have only one good integer, that is 11. When we add them, so this will give 2. Okay, so here we can see the total number of best integers out of these two, which is matching the sum either 3 or 5 in the sum, that is this only. That means 12 and 21. That's why we have got 2 as the output for this one. Okay, so how exactly we are doing this one? So here if you can see this, then we are doing the NCR, that means number of ways, that means NCR, that formula is there, that NCR. So the number of ways we select R from N. Okay, so here NCR, if we do NCR for 2C1, then we get the answer as 2 only. So that means the number of that means out of 2, the number of ways we can give one place to A and one place to B. That means for I is equal to 1, that will give 2 output. That means we are finding the different combinations for the scenario where one slot was given to A and another slot was given to B. Okay, so we got 2 scenario here. So when we do NCR, then that is equal to 2C1, it will give 2 only. That's why we have got 2 output here. Okay, so I hope the approach is clear to you. So using this approach only, I have prepared one solution. So let me just copy it here. Okay, so whatever the approach we have discussed there, the same thing we will be doing here. Okay, so here if you look at this code, then the solution first initializes some constants and pre-computes some values that we require for calculation. Okay, the initialize method here, what is that? Yeah, the compute factorial method. So we are what we are doing, we are kind of initializing some max size, mod, factorial, inverse factorial, this number we are first initializing it, then we are going inside this best numbers. So what we do, first we try to compute some factorials. That means the factorials which we will be using for the formula of NCR. What is NCR? N factorial divided by n minus r factorial into r factorial. So for that we compute all the factorials here. Okay, then we start our analysis for the same scenario, whatever we have discussed there. If A is equal to B, here if both the numbers are same only, if in the given example, if A is equal to B, then what is the total sum there? Then the total sum will be n into A. Okay, so here whatever this solution is directly computing this part. If you look at this part, that means it is adding the sum, it is doing this calculation, and we are directly checking this sum, whether the sum contains that value or not. Okay, so if both numbers are same, so what we can do, we can directly multiply the length of that number with that number, so that will become a sum. If sum is greater than 0, then what we do, we check that at any place in that sum, does it contain C or D? If it does, then we return 1, and what we do, then we reduce the number by dividing it by 10, because here we are doing the modulus operation by 10, so that we can check for each digit. So for reducing the number for the next modulus operation, we are dividing it by 10. Okay, and if no such number is found, that means that means there is no best number, that's why we return 0. So this was the one scenario. Okay, when we talk about the actual scenario, that means the different combinations here, so what we do, we iterate through the loop here, and we try to compute sum using the same way, the way we did in the example there. That means I into A plus n minus I into B. That means the number of positions we are giving for I, and the number of position I that will be given for A plus number of positions we will be giving for B. So when we add all of them, then we will get the sum. So here this will contain all the scenario here, when n is equal to 0, I is equal to 0, I is equal to 1, I is equal to 2, everything. I hope this is clear. Then what we do, then here we add the sum the way we added here in the example here, and we initialize the is best flag as false. Then we check if the sum is greater than 1, the same scenario which we did for above was the base case. So now we are doing in iteration. If the sum is greater than 0, then we check if the sum contains C or D. That means in the sum any digit contains C or D. If it does, then we mark is best as true. Then we break the loop here. Okay, and if it doesn't, then we again check for the next digit, next iteration in this for loop. So that's why we divide sum by 10. Okay, so after this, when we check that if we found is best as true, then what we do, we simply calculate NCR with n and I. That's it. We simply calculate NCR. Whatever the answer we get, that we do modulus by mod, because that has been asked in the problem. that since the number of best integer can be used, print it modulus 10 to the power 9 plus 7. So that itself is the answer. But how do we calculate NCR? That means NCR means n factorial divided by n minus r factorial, then after that r factorial into r factorial. Okay, so if when we see this calculate NCR method, then here we can see factorial n factorial. Okay, so instead of division here, it is here multiplication of inverse factorial of n minus r and r. Okay, so if I try to write here the exact formula, let me just try to write here n c r. Can I write it down? Something like this. If we try to write here, then what will it be? It will be n factorial, then it will be, okay, here only we can write n factorial divided by n minus r factorial into r factorial. So this is the formula of NCR, n factorial divided by n minus r factorial into r factorial. So here we can see this division operation is there, but if you look at this formula, then we are doing n factorial into n minus r factorial into r factorial, but here is the inverse factorial here written. It's not the factorial, it's the inverse factorial. So what is the significance of inverse factorial? So in mathematics, the inverse factorial denoted by that factorial to the exponential of -1 is a function that maps each positive number to a large real number such that x factorial less than n. Okay. In this context of this problem, to calculate the value of NCR, we can compute the factorials of all the numbers up to max size and their inverses and store them in an array. The inverse factorial is used to store inverse factorials. The array is used to calculate the denominator of NCR formula, which is r factorial into n minus r factorial. So whatever it was there in this formula, the denominator part, that we are computing using inverse factorial here. Okay. So inverse factorial array is computed using the formula of inverse factorial of I, that is equal to I plus 1 into inverse factorial of I plus 1 mod mod. Okay, see the funda of inverse factorial here is that when we do factorial of I into inverse factorial of I, that is equal to 1. Okay, so here if I try writing that one, that means factorial of fact of I into inverse fact of I, then it should give 1. So what exactly is that? It can be considered as fact of I divided by inverse fact of I. If this is the scenario, then only it is possible that inverse factorial of I into factorial of I is 1. Okay, where factorial I is the factorial of I. We can use this fact to inverse factorial recursively. Okay, using the inverse factorial array, we can calculate NCR using the same formula of NCR, that is factorial of n into inverse factorial of n minus r into inverse factorial of r. Okay, this formula is based on the original formula of NCR, where we divide. In original formula, we divide the factorial of n by the product of factorial of r and n minus r. However, in inverse factorial, we can replace the division with multiplication, which is much faster than division. So just to obtain it in a faster way, instead of dividing it, we have multiplied it with the inverse of the factorial. Okay, inverse of the factorial means exponential to the power minus 1. When we do minus 1, that a to the power minus m, then it becomes 1 by a to the power m. I hope that law of indices that is considered here. Okay. So I hope this point is clear. So inverse factorial array is significant in this code as it allows for the efficient computation of binomial coefficient which is required for the solving the problem here. So that we are doing. But when we look at this inverse factorial method here, so it is trying to calculate the inverse factorial using the calculate power here. So what is the significance of calculate power here? The calculate power method is used to calculate the modular inverse of factorial value here in this code. The modular inverse of A is defined as the value of B such that A into B is congruent to 1 modulo to the given M. The modular inverse is useful in calculating combination of NCR modulo a given number. Okay, so if you try to find this factorial n factorial using this formula, it will be n factorial to the power minus 1 and n factorial to the power minus 1. That is equal to n factorial to the power of m minus 2 modulo m. Okay, so using this only we have calculated this one. So this gives a better efficient way of calculating the inverse of a factorial. So when we get the inverse of the factorial, then what we do, instead of dividing it, we can just multiply it for a number. Okay, so using this approach only, we have just calculated is NCR, and whatever the value we have got in this answer, we are just doing a modulus or using mod. Okay, so this was the complete solution of this program. So I hope this solution is clear. Here we are again using the simple formula only. We are just finding different combinations to different ways to get a good numbers. Then we check among the good numbers which is the best. And when we get one best number, then we can say in how many ways we can rearrange the best number. So here one best number was 12, but it can be rearranged as 21 also. That's why we got the two best number. And how we are doing that rearrangement? We are using NCR. Okay, so let's try compiling this code. Okay, again I've copied in wrong window. This is Java. Let me copy this code here. Or let me move to this and copy it from again here. So I'll replace this entire code. Yeah, this is in Java editor now. So now let's try compiling this code. So here we can see we have got correct output. Let's try submitting the solution. So here we can see we have got all the test cases covered. So this problem has been solved successfully. Okay, so talking about the time complexity solution, it is in the order of big O of n for pre-computing factorials and inverse factorials, and big O of n for looping through all possible values of I. Within the loop, the time complexity is log of mod. For calculating modular exponentiation using binary exponentiation method and big O of 1 for other operations. Therefore, the overall time complexity of the solution is n log mod. However, since mod is a very large prime number, log of mod is less than or equal to 31. So the time complexity can be considered as approximately big O of n. Okay. So I'll provide the link for this question and the code for this in the description box. Please do check that. That's all in this video. Please like, comment and share the video, and please subscribe to the channel for more upcoming videos. Thank you for watching.